inverse trigonometric functions, we're first going to look at the sine function. The red graph that I have drawn here is your sine function, sine of x. Now, in order for it to have an inverse, we need to be 1 to 1. So we're going to restrict our domain to just the blue area. That way it passes the horizontal and the vertical line test. This then creates our domain between negative pi over 2 and pi over 2. Now the inverse is referred to as arc sine of x, or you've seen it as sine inverse of x. Either one, it means the same thing. The textbook switches between the two. When you take the inverse of sine, the domain and the range, as you can see, are going to switch based on these restrictions that we set up above. So for every one of these sine, cosine, cotangent, secant, and cosecant functions, we're going to set restrictions for each of these. These are the general restrictions that the textbook will use in general on how to restrict things. Cosine will go from 0 to pi, tan will go from negative pi over 2 to pi over 2, cotangent will go from 0 to pi, secant and cosecant, because they have asymptotes in them, will go from 0 to pi over 2, not including pi over 2, and then from pi over 2 to 1. Cosecant is going to go from negative pi over 2 to 0, and then from 0 up to pi over 2, again not including the 0 because of the asymptotes. Now this graph here, just for your reference, is your sine inverse. So you can see it goes from negative 1 to 1 based on the restriction, and it goes from here at negative pi over 2 to pi over 2. The domain and the range have switched between the two based on the restricted domain. Now for sine of theta equals to x, we can actually create a right angled triangle that will give us all the ratios based on opposite of our hypotenuse. Now we want it to be equal to x, so x is the same as x over 1. So our opposite side would be x, and our hypotenuse would be 1. So this is just setting up so it matches what we would like here in terms of this equation here. Then we can use Pythagorean theorem and do 1 squared minus x squared, and then square root it to find the other side. So why this is important is because we're going to look at the derivative of sine inverse. Now we know that we can find the inverse's derivative by taking 1 over the original function's derivative with the inverse plugged in. So in this case, my overarching function is sine of x, that's my original function. Its derivative is cosine of that, and the inverse is sine inverse of x. Now because of this, we can now use cos of x to figure out the denominator, which works out to 1 over the square root of 1 minus x squared. So that is how you find the formulas, by using this triangle and using the cosine ratio for the sine inverse. Now using the same sort of concept, we can also find the cos inverse derivative, which, because we know that sine and cos, one is positive, one's negative, when we take the derivative, this one will become the negative, because cos will go to negative sine. Now finding the derivative of all the different inverse trig functions is based on setting up these triangles. Same sort of idea. To find your sine, cosine, you set up the triangles with the 1 over 1 and x, and then you do the 1 over the function's derivative with the original function, or the inverse function plugged in. Then we also have the tan inverse and the cotangent inverse. If you notice again, the difference is only sine. And for secant inverse and cosecant inverse, it's a little bit more complicated, but as you can see, it's based on the absolute value of x, and again the square root of x squared minus 1. Now for the integrals, because if you notice here, every single one of these is a negative version. When we take the integral and we have 1 over our square root of 1 minus x squared, it looks like it'd be sine inverse or cos inverse. Assuming it's positive, we're working with sine inverse. Even if it's negative, the negative will come outside. If we have x squared plus 1, then we got tan inverse. If we have the absolute value of x and the square root of x squared minus 1, it's going to be secant. So we take the positive version for all of these. So now we can use all the derivative formulas and all the integral formulas, and using either chain rule, product rule, quotient rule for the derivatives, or use substitution, we can use all of these to help us figure out what the derivative and what the integrals are.